In this video, we'll be discussing about the types of EHT substations, that is the classification, design and applications. Here we have the following learning objectives, that is the classification criteria, the comparison between different types of substations, and identify which substation is suitable for which type of site conditions, for the specific site conditions. So these are the five types of classification, that is based on function, based on design or layout, based on insulation medium, based on installation location, the comparison, case study and examples with our summary at last. So what we say about EH substation is the voltage level is more than 33 kV and up to 765 or higher, that is AC transmission. Functions, the substation allows for power transformation from one voltage level to another voltage level for transmission, and again for distribution we have step down operations like that, and different switching operation based on the requirement, and the necessary protection and control equipments for the substation operation. So these are the following equipments that are there primarily in a substation, that is a transformer, the circuit breaker, the CT, the PT, that is the current transformer, the potential transformer, bus bar, relays and so on. So these are the details of the components and the layout. You can see this is an AI generated image, the characteristics, the voltage levels, the purpose, application, the line diagram, everything has been mentioned here, and the function of individual equipment also being presented. So, after knowing what are there inside the substation, let us now find out, based on the function, what are the types of substation. So first one is step up substation, which is located the near the generating stations, where we get voltage at max 11 or 33 kV, and then we have to raise the voltage for higher value for transmission, and that may be 132 or 220 or 400, and these are from conventional hydro, thermal or nuclear plant. Then comes the step down substations, wherein again from our transmission network it goes to the distribution level, and that may be 220 by 132 or 220 by 33 and 220 by 132 by 33, and these are the utility receiving stations. In Odisha we have OPTCL, central level we have PGCIL. Similarly, switching substations, where we don't have any power transformer, only switching and protection action takes place, and that is used for interconnection of different transmission lines. Similarly, we have industrial or traction substations. For railways, we use 25 kilovolt AC, and that are being all the substations, RTSS, railway traction substations, RTSS, that is connected to the state grid from 132 kV level, and there is a substation near to the RTS railway station, which allows for transformation of the power, and these are also used for special metering and reactive power compensation. And this is the summary of the whatever I said. Here you will find another one, that is the pooling substation, which is now gaining more popularity because of penetration of high renewable sources, that is solar, wind, and another is like we call digital substations, where we have more number of digital communication and intelligent electronic devices for the automation, monitoring and protection control purpose, that can be done with high speed and accuracy. All other substations that we have discussed in the last slide, that is also mentioned here. That is, we have generation substation, pooling substation, grid substation, distribution substation, and at last we come to the consumer premises. Similarly, classification based on design or layout. The substation can be outdoor, can be indoor, or a combination of both outdoor and indoor. So whenever we find the substation equipment that is there outside in air medium and installed in open switchyard, that is very easy to maintain and economical, whereas indoor substations are housed within a building and suitable for space constrained or urban locations, and hybrid is more mix of both. So this allows compact footprint as well as moderate cost. Here you can see two types of substations on the left hand side of the screen, that is the GIS, gas insulated substation. On the right hand side, that is the air insulated substations, where in GIS we use SF6 as the insulating medium for the equipments. So when we go for AIS or when we go for GIS, that has been told in the earlier side, like the measure is the criteria is the space. If space is a constraint, then GIS can reduce the substation size to a compact level, and the GIS switchyard require less maintenance because it is not exposed to the outside environment, but at a higher cost. So we can see installation, operation and maintenance wise the difference between AIS and GIS. Next comes to installation location, that is the conventional ground substation built on open land with control room. Second one is underground substation for urban and metro areas, and mobile or container substation, that is skid mounted or trailer type used for emergencies or temporary supply. Here you can see one indigenous developed Make in India project by Toshiba for power grid PGCIL. This is the 220 kV mobile GIS bay. See how compact this one, and this can be used for emergency temporary supply, and it can be rapidly deployed in the area, and it is quite flexible. Next comes the supply. Most of the time we have discussed is about AC transmission and the HVAC network. Similarly, we have HVDC network also for long distance transmission. There is a break-even point up to how much kilometer HVAC is viable, and after how much kilometer the HVDC should be used. And for solar and other sources also, DC network is quite feasible. That also being employed as HVDC, and it is very much suitable when transfer happens between two asynchronous systems. HVDC allows that feature. Similarly, for submarine also. Now we have come across these substations, and the summary is like AIS or GIS and hybrid. Three types are there. AIS, where space is abundant and it is mostly for rural or industrial areas. Similarly, GIS is for urban and critical or underground use, and hybrid is takes the balance between both of them. Next comes the single line diagram, where you can see 33 by 11 kV single line diagram here. Here we have the CT, PT, isolator, protections, SF6 breakers, and transformer isolators, and the individual functions, whatever we have seen earlier, like why these devices are needed. Most of us know transformer is for either stepping up or stepping down the voltage. Similarly, circuit breaker is required for auto disconnection, and both during normal and abnormal condition for disconnection of the circuit, current transformer for transforming the current from high to low, that can be used for control and protection circuit, and PT also. Similarly, isolator for auto disconnection, air disconnection for safety and maintenance, earth switch, relay devices, lightning arrestor, earthing, gravel, everything. And next, in our next video, we'll be discussing about the bus bar. The bus bar, which is a conductor used to connect two or more equipment located side by side when the currents are very high. So this will be discussing in the next video in detail what are the types of bus bar in a substation, and what are the types of bus bar arrangements we see in our substation, EHD substations. Thank you for your patient hearing.